Aubin Subsea specialises in developing materials technology for the subsea industry. Our team has developed pumpable liquid buoyancy materials, Liquid Buoy and Deep Buoy, and we've engineered a variable deployment system that offers precise control when moving structures subsea.
The main challenge of subsea lifting or deployment are safely raising and lowering any loads, typically by heave compensated crane.
The Liquid Buoy system we're testing today is a low density pumpable buoyancy system for subsea lifting. It's similar to that of commonly used airbags, but as it's a liquid, it's incompressible. You can have the potential to go to low depths, great pressures, while maintaining the same buoyancy and fluctuations, therefore it's more controllable.
The aim of the trial was to test Aubin's liquid buoyancy system in actual operational conditions. We plan to put it through a series of tests which simulate real life situations.
I was introduced to this product via a colleague, and he told me that this is something you need to see. So I looked through the documentation and yes, I want to see this.
There isn't really an alternative solution for deep water operations other than launching pump weights with high buoyancy.
I think with the increasing importance of technology to the industry, this type of operational trial becomes more and more important. It's vital to the success of any trial to plan it very carefully to make sure the time here is as productive as possible. So there's been a lot of planning involved in working with Aubin to make sure this is a successful trial.
Once the lifting bags have been deployed, the spool piece is lowered and attached to the lifting bags by the ROV manipulator. The hoses, which are pre-filled, are paid out and the bags are lowered to allow the liquid buoy to be pumped. When pumped, the gel instantaneously provides buoyant lift. The bags are filled with enough liquid buoy to render the spool piece neutrally buoyant. The crane is then detached and the liquid buoy bags hold the spool piece independently. This allows an ROV to manoeuvre and control the structure with ease, something that has previously been impossible to do.
Our liquid buoy trials went very well. The spool piece we used was made neutrally buoyant, which made it manoeuvrable by the ROV.
And once it was able to be equalised in the water, it was practically stationary for the whole time, and witnessing the work class vehicle moving the load up and down, it made it look like a very easy job indeed.
Yes, very impressed with the trials. I think there's a lot of applications that Liquid Buoy could be used at. I was quite impressed with the fact that an ROV can go down and take hold of a subsea structure, subsea load, and control it.
I think the buoyancy gel product could be very significant for offshore operations, where you have to adjust buoyancy in the middle of the job.
I could see a whole world of different applications, whether it be for dive support or in the deep water operations.
Tooling, spool pieces, everything that needs to be moved subsea is probably going to be easier with this.
The Liquid Buoy system could potentially remove the need for expensive construction vessels where active heave compensated cranes are generally used.
And also, as for the handling on deck would be much safer.
I see various applications, particularly in the salvage field, but also in probably rigid jumper installations. Liquid Buoy by its own could be used to install these in a safe, controlled method.
The system was very easy to deploy and recover, very much a seamless transition from deck to depth. And obviously its capabilities were well and truly improved.
The technology used in this system, it's fantastic.
You pick up the load neutrally buoyant and easily manoeuvre that to the particular structure.